Hello, this is for CIS 200 Unit 1 challenge work. Now, this is on Lesson 1, Page 6, Unit 1 challenge work. You would launch activity by clicking it right here, and it will open in Cengage. So sometimes these questions are ordered differently. That is all right. So we're going to start with question 1. So assume we have a computing agent that knows how to do one-digit subtraction, where the first digit is at least as large as the second. So on and so forth. Please read through the question. I'm going to go ahead and work on it right now. So we just call it Unit 1 challenge work, and go ahead and call this one Q1. So now we just need to lay out what we need to do. So we'd say something like solving like a computer. Keep in mind, it does not need to be necessarily grammatically correct, so long as you convey the idea. So we're going to say process the numbers column by column from right to left, starting at index I equals 0 up to index m minus, excuse me, m minus 1. And keep track of whether we need to borrow from the next column as we are, you have to borrow in subtraction, right? So we can go ahead and just number it out. It doesn't have to be numbered. This is just how I choose to lay out the algorithm. So we're going to say for the first step, set the column index I equals 0 and borrow equals 0. For part 2, we're going to loop through each column. If I is less than m, do the following. Apply any existing borrow. Subtract the current borrow from the top digit. Compare digits. Should be a lowercase I. Compare digits. So we'll just call this like case 1, as in what could happen. We should state what it is. So in case 1, we're going to say if a sub I is greater than or equal to b sub I, should be i's for the index. We will go ahead and say c sub I equals a sub I minus b sub I. And then we set borrow equal to 0 because the top digit A is bigger than the bottom digit B, and C will be the difference of those two. So if you have 19 minus 12, 9 minus 2 equals 7. So in that instance, 9 is A, B is 2, and so 9 minus 2 equals 7, which is C. And then we can go ahead and make case 2. Essentially, the borrow is needed. Borrow is needed because A sub I is less than B sub I. That is, if you have 12 minus 19, 2 minus 9, you cannot do, so you'd have to borrow from the next column over. You're going to say C sub I equals A sub I plus 10, right? Because when you borrow from the next column over, you're essentially bringing a 10 over. So 2 minus 9, if you borrow a 1 from the next column over, it becomes 12 minus 9, right? Minus b sub I. So this is just basic subtraction, right? We're just laying it out algorithmically. Then you're going to set borrow equal to 1. Now we've gone over our two cases. So now we'll say we're going to move to the next column, that is move left. We're going to increase I, that is the index, by 1 to move to the next column. And then, I'm sorry, that is actually the last step in the loop right there. Okay, so now the final step is going to be essentially finish. Remember, we loop through them all the digits. So 191 minus 112. We do 1 minus 2, borrow accordingly. 9 minus 1 or 8 minus 1 since we borrowed, and then 1 minus 1. So this entire loop covers all the digits. If it's two-digit numbers all the way up to, any amount of digits, 30-digit number minus a 30-digit number, we keep this loop going until there's nowhere left to move to the left, the next column. So the final answer is represented by the C digits, C sub m minus 1, C sub m minus 2, etc., all the way to C sub 0. So let's look at it real quick. 119 minus 112. Actually, let's do 112 minus 109. So can you do 2 minus 9? No. So you have to borrow this one. It becomes a 0. So this is now 12. 12 minus 9. So we'd have C sub 0 equals 3. And then you now have 0 minus 0, which is 0. So C sub 1 equals 0. And then 1 minus 1, which is 0. So C sub 2 equals 0. So the final answer would be 003. Of course, we dropped them off, but as far as algorithmically, the answer is 003. Now you'd go ahead and you would save this, right? So let's go ahead and we click File, Save, etc. Um, but I want you to see us save it as a PDF, right? So we go somewhere and then we would go ahead and you can save it as a docx, right? But for submission, go ahead and save it as a PDF, submit it, and then you can go back to this document. And if you want, you either open up a new one or you can just do Q2 right below, right? Let's see what Q2 says. You would submit it right here. You click upload file, search out that PDF, submit it, and then move on to the next question. So this is about the definition of the field of computer science. So I want us to talk about what computer science is. Please still read through the question. Anytime it wants like a report or anything written like this, just a couple sentences will suffice. So we would just say something like, computer science is defined in many ways because it is still a young and evolving field. Go ahead and scroll up. Young and evolving field. So while the textbook from your reading defines it strictly as the study of algorithms, as many textbooks do, the famous 1989 ACM definition calls it the study of processes that transform information. So we want to just put that in quotes, right? So this mixes a lot of things, right? This mixes, what does it mix? It mixes math, science, and engineering, to name a few, while other modern definitions focus simply on problem solving and designing software. So this is enough to suffice and to satisfy that question too. So you do the same thing. File, save it, of course, normally by clicking the save icon. Then you click save it as a PDF. Go ahead and submit it right here and upload files. Then move on to question 3, history of computing in the US and the UK. So take a look at the article mentioned and write a report. Again, just a few sentences on the fundamental contributions to computing from one specific scholar or one specific country. So now we can go ahead and just call this Q3, right? And we can talk about, I mean, there's, an infinite amount of people. So I'm just going to pick one. So in his article, Herbert Bruder highlights Germany's fundamental contributions to computer science. Go ahead and scroll up. These contributions are most notably through Konrad Zuse, very famous computer scientist. In 1938, Zuse built the famous Z1, followed by Z3 in 1941. This is widely recognized as the world's first fully functional programmable and automatic digital computer. Let's see, should we add anything else? What do I got? I've got about 4 sentences, so yeah, let me try to add 2 more. His work, so Zeus's work proved to be invaluable in European engineering. It independently laid the groundwork for modern computing in the mid 20th century. Something like this from the article and your research, just a couple of sentences, nothing too fancy. Doesn't have to be multi-paragraph research paper, right? So you'd save it, then you'd file save as, convert it to a PDF, click save, and you would go ahead and upload this. And those are the 3 questions for the Unit 1 challenge work. Thank you very much. I hope that this video was helpful. Have a great rest of your day.